Okay, today in class I passed out what I'm going to refer to as a foldable. We're going to use it to review for our quiz tomorrow on complementary, supplementary, and vertical angle relationships. So we're going to start on the front if you want to fold this piece of paper the hot dog style, and you can cut along these lines to create flaps. On the inside, you're going to notice the definition. So complementary angles are a pair of angles whose sum equals 90 degrees. So one of the things that's helpful, if we can draw ourselves a little hint or give ourselves some way to remember the difference, particularly between complementary and supplementary, well, we're going to start with a C, and then we're going to connect the two ends of that C to make a 9. So this is one way to remember that complementary angles add up to 90 degrees, not 180. When we have supplementary angles, we're going to start with the S. And again, we're going to connect the ends of the S to make an 8. And then we're going to draw in 180 degrees. So that's one way to remember that supplementary angles are a pair of angles whose sum is 180 degrees. Now for vertical angles, their vertical angles are across from each other and they're equal, are congruent. So complementary and supplementary add up to either 90 if they're complementary or 180 if they're supplementary, but vertical angles equal each other. And one of the ways I remember it is that vertical V, if I took two intersecting lines and I looked at this as a V and this is a V, they're pointing to each other. So these two angles across from each other are exactly the same. Vertical angles are across from each other. Vertical angles form a V pointing to each other. And so those are the little helpful hints. Now, if you open up the flap or look on the inside, we're going to talk about several different scenarios. We're going to talk about angles are next to each other, when they're apart, and when they're embedded in a diagram. So this first word next to each other is a special word, and we call those adjacent angles. They share a ray. So in this case, I'm going to draw a right angle. And when I have another ray coming through this, then I have angle A and angle B are now complementary. No matter what measurement they give us, we're able to figure out what the other measurement is. So if I knew that angle A was 50 degrees, then I could take 90 minus 50 and know that B is 40 degrees. Sometimes they give us angles that are apart from each other. So if they were to show me an angle that was, say, 20 degrees, and they would tell me that this is 20 degrees, and then this angle was 70 degrees, I would know that these two angles are complementary because the pair of angles, their sum would add up to 90 degrees. Please copy down this diagram with me. We're going to have two perpendicular lines, which means that this forms a 90-degree angle. And then we're going to have another intersecting line that comes through the vertex. And by embedded, I mean that there is at least one pair of complementary angles. So if they told me that this was 65 degrees, based on the fact that I see a 90-degree angle right here, well, this would be 90 degrees, this would be 90 degrees, and this would be 90 degrees. So I now know that these two angles, the relationship of these two angles, is complementary. So I would again take 90 minus 65, we have 25 degrees. So this angle here would be able to figure out is 25 degrees. even though the diagram has much more going on, we'd still be able to use our knowledge of complementary angles. Now let's move on to supplementary angles, which are a pair of angles that add up to 180. So we're going to start with a straight line, and then we're going to create a vertex, and from that vertex we're going to write another ray. So if I knew that this was 30 degrees, then 180 minus 30 would give me 150. So I'd also know that this angle is 150. Sometimes they can do the same thing. They can give me, for instance, an obtuse angle, and they can give me a acute angle, and as long as they tell me they're supplementary, I would know that they add up to 180. So for instance, this might be 110 degrees, which would make this 70 degrees. And an example of embedded would again be if we'd started with a straight line, and then we used another straight line that crossed over it. So in this case, we would have more than one pair of supplementary angles. I'm going to call this A, B, C, and D. So if I look at this, if I just concentrate on A and B, the first one that I drew, these two angles would be supplementary. They would add up to 180. But we could also find another pair of supplementary angles. In fact, if I went from B to C and looked at this straight line, then those would also be supplementary. B and C are supplementary. And we could continue to do that. If I started at C and went across and arced over to D, then this would also be a supplementary relationship. And last but not least, we could do exactly the same thing with A and D. So there's 4 different sets of supplementary angles there. Okay, now let's continue with vertical angles. Vertical angles are across from each other and are equal. So let's start again with a diagram of 2 intersecting lines. Okay, now if we're looking for vertical angles, remember those V's. If I write a V like this, 2 V's that point to each other, that are across from each other, those angles are congruent, which means that they have exactly the same measurement. But I also have another set of congruent angles, and these are also congruent. So we also not only have vertical angles in this diagram, we also have supplementary relationships. So that's what makes it complicated. And we often have, we refer to, unless it's perpendicular, we have a pair of obtuse angles, and we also have a pair of acute angles. So you will probably be asked to identify or name the measurement of the acute angles and of the obtuse angles. Because once we know just one angle, we're going to be able to find out the rest of the angles. So let's demonstrate that. If someone told us that this angle right here is 110 degrees, well, I would then know directly across from it, this is also 110 degrees, and those are obtuse measurements. So if we wanted to know the acute measurements, the ones that are smaller right here, well, that's when our supplementary relationship would come in. We would take 180 minus our 110 and get 70. And once I know one of these is 70 degrees, then directly across from it, vertically across, this is also 70 degrees. So let's spend a little bit more time. I know this is going to be a long video, but let's talk about when we involve algebra in solving. Okay, would you please go to the back of your foldable? You should find some blank space on the very back, and behind the complementary, would you write this first diagram? Behind the supplementary card or flap, would you write this and diagram, and then on behind vertical, would you write this? Please pause the video, and when you're ready, go ahead and replay it. Okay, in order to solve this very first one, we have to recognize that this is a complementary relationship. So we're going to take what they give us, which is 4x plus 2x. Those are the two measurements right now. But we have to say that they equal 90. So they are complementary. We would then combine these like terms to get 6x equals 90. And then we would go ahead and divide both sides by 6 to get x equals 15. So now we know what x is, but we don't know what the measurements are. So we would take 4 times our value, which is 15, and 2 times our value, which is 15. And in this case, this would be 60 degrees, this would be 30 degrees, and those do indeed add up to 90 degrees. The next relationship is supplementary, which means they're 180 degrees. So I'm going to take what they give us, 2x for the first angle, plus 5x plus 5 for the second angle, and together those equal 180 degrees. So once again, we're going to gather up our like terms. So that's 7x. This term is different, it's a constant, plus 5, and that's going to equal 180 degrees. Now our solving steps begin. We're going to eliminate the constant by doing the opposite of adding 5. We're going to subtract 5, and that's going to leave us with 7x, because we've eliminated that, equals 175. We'll continue to solve by dividing by the coefficient, the number in front of the variable. So we've eliminated 7, and that gives us x equals 25. So again, we're not done. We would say 2 times 25, so this angle is 50 degrees, and 5 times 25 is 125 plus 5 more, so this would equal 130 degrees, and 50 and 130 add up to 180. So now let's try our last one. We have to realize that the last relationship is vertical. They point to each other, across from each other, so they equal one another. So this would be 3x plus 10 is equal to 5x. And now in order to solve this a little bit trickier, we have variables on both sides. And we don't want a term with variables on both sides. So we're going to eliminate one of the one of the terms with variable. So I'm done with this entire term, which leaves just positive 10 on this side. If this would have been a minus, we would have written it as negative 10. And on the other side, I have 2x. If I had 5x and I took away 3 of them, we have 2x. And we're going to complete our solving by dividing by the coefficient of x. We're eliminating 2. We have to do it on both sides. So now 5 equals x. So one more time, to find the measurement of this angle, we would take 3 times 5, which is what we said x was, which would be 15 plus 10. And so this angle measurement right here is 25 degrees. Now, we should get exactly the same measurement on the other one. If we took 5 from this 5, and then we substituted x, we substituted 5 for x, 5 times 5 is indeed 25 degrees. We could continue this and find out the other 2 angles, the obtuse angles, by subtracting 25 from 180, and we would get 155 degrees for both of these angles too. So thanks for listening. I hope this is helpful for your study, and good luck on your quiz tomorrow. Bye-bye.